everyone, these are the proportional relationships guided notes. We are going to start by defining a proportional relationship, and then we're going to dive deeper into what that actually means. A proportional relationship is when the ratio between two variables is constant. Let's talk about what that actually means. Let's dive into equivalent ratios. You can test for proportional relationships by checking if two ratios are equivalent. Ratios that are equivalent have the same multiplicative relationship. You can analyze the relationship in two ways, both vertically and horizontally. Let's see what that looks like on these examples below. Let's look at the vertical. So if you notice, if we look at this vertically, meaning the numerator to the denominator, I can get from the numerator to the denominator by multiplying by 2, and that is the same for both ratios. Since the vertical multiplicative relationship between the numerator and the denominator is the same, the ratios are equivalent. This is also true if we look at the horizontal relationship. So numerator to numerator and denominator to denominator. So in this scenario, I can get from the numerators by multiplying by 3, and that is the same for the denominators. Since the horizontal multiplicative relationship between numerators and between denominators is the same, the ratios are equivalent. Let's look at some ratios that are not equivalent. Starting here with this left, if we look at the vertical relationship, meaning denominator to denominator, with the first ratio, the relationship is multiplying by 4. 3 times 4 is 12. However, if I look at the second ratio, the relationship is 5. 4 times 5 is 20. Therefore, since the multiplicative relationship is not the same in each ratio, that means that the ratios are not equivalent. Looking at the second ratio, let's look at the horizontal relationship. I can get from 3 to 4 by multiplying by 4/3. However, I can get from 12 to 20 by multiplying by 1 2/3. Since the horizontal multiplicative relationship between the numerators and denominators is not the same, the ratios are not equivalent. Here below, we are going to create an example of a relationship that is proportional and a relationship that is not proportional. Let's start with one that is proportional. Let's start with, for example, 4/5. As long as their multiplicative relationship is the same either horizontally or vertically, it's going to give me equivalent ratios. Let's try multiplying both of them by 2 horizontally. If I multiply the numerator and denominator by 2, that will give me 8/10. 4/5 and 8/10 are equivalent. Let's give an example of a relationship that's not proportional. Let's start with the same 4/5. To make it not proportional, I have to have a different relationship either vertically or horizontally. So I can multiply the top by 2, and if I do that, let's multiply the denominator by 5. So then I have the ratio of 8/25. And 4/5 does not equal 8/25. Therefore, that is an example of a not proportional relationship. If the vertical multiplicative relationship is the same, will the horizontal multiplicative relationships always be the same as well? Explain why or why not. The answer to that question is yes. If there is a horizontal multiplicative relationship, there will be a vertical multiplicative relationship as well. Checking for their multiplicative relationship both horizontally and vertically is not necessary. However, knowing that they both exist is helpful because one may be more obvious than the other. For example, if I'm looking at these equivalent ratios right here, I may notice that 3 times 3 is 9 and 7 times 3 is 21 before I notice 3 times 2 1/3 is 7 and 9 times 2 1/3 is 21. So knowing that they are both there is important so that I can easily find one or the other. Explain how you can use equivalent ratios to test if there is a proportional relationship. I can check if there is a multiplicative relationship either vertically or horizontally. Again, I don't need to check both, but if I find one vertically or horizontally, then I know that the ratios are equivalent. Check to see if the following ratios show a proportional relationship. Draw arrows and write the multiplicative relationships. Let's look at the first one. I might notice that 6 times 4 is 24 and 2 times 4 is 8. I don't need to check the horizontal one as well, although I am in this case just to show you. I can notice that 6 times 1/3 is 2, which is the same as divided by 3. So if you see a division relationship, you can change that to multiplicative. That's going to be the same idea. Or 24 divided by 3 or times by 1/3 will give me 8. So yes, that is a proportional relationship. Let's look at number 2. We're going to start with horizontal on this one. I can notice that 1 times 3 is 3, but 5 times 3 is not 7. So that is not a proportional relationship. Number 3. I'm going to go with this vertical here because I can quickly see that 5 times 3 is 15. 8 times 3 is not 18. That is not a multiplicative relationship. Number 4, I notice that 6 times 2 is 12 and 11 times 2 is 22. Right here, horizontal. There is a multiplicative relationship between 6 and 11, 12, and 22. I know that because their horizontal relationship is there. I don't know right off the bat what it is, so I'm not going to worry about checking it because I already know that the horizontal relationship is there. Therefore, this is a proportional relationship. In a similar manner, we can use tables to test for proportional relationships. Proportional relationships in tables will also have a multiplicative relationship, both horizontal and vertical. So it's the same idea as ratios, we're just seeing it in the table. Notice that the multiplicative relationships in this table here below, note, this does not show all the multiplicative relationships. So if we look right here, the vertical relationship between the x and the y is always multiplied by 2. That will be constant in a proportional table. If we look at the vertical relationship, notice that if I go, for example, if I go from 1 to 3, and then the same distance down here below, 2 to 6, that is multiplying by 3. Okay, now I'm going to go to a new one. If I go from 1 to 5 over here, that's multiplied by 5, to the same distance, to 10, is also multiplying by 5. Or I can even go from 4 to 8. 4 to 8 is multiplying by 2. Therefore, 2 to 4 is multiplying by 2. Or I may even notice that 2 to 5 is 2.5, and 4 to 10 is 2.5. So going across, I can notice that the multiplicative relationship stays the same when I'm going to the same column. Show at least 4 multiplicative relationships on this table. So let's first look for the one between x and y. The one between x and y is going to be multiplying by 3, and that is consistent the whole way down. Let's look for some more. I notice 2 times 5 is 10, and then going the same distance down at the bottom, 6 times 5 is 30. I notice that 5 times 3 is 15, and same distance on the bottom, 15 times 3 is 45. I notice that 2 times 3/2 is 3, and 6 times 3/2 is 9. Let's look at this table here. We are to explain why this table below is not a proportional relationship. Let's look at the relationship between the x's and the y's. If I'm going from 1 to 2, that's multiplied by 2. 3 to 9 is multiplied by 3. Technically, I don't even need to go anymore because I know if I'm looking at the relationship between x and y, it has to all be the same. But I'm just going to look at some more. 1 to 5 is by 5, and 2 to 10 is by 5. Now that's the same, but every relationship has to be the same. So just because I found one that is the same doesn't mean that everything is the same. Let's look, for example, at 1 to 7. 1 to 7 is multiplied by 7. 2 to 28 is multiplied by 4. So these are not the same. For my explanation, I'm just going to explain that the multiplicative relationship between x's and y's is not constant. Explain how you can use a table to check if the relationship is proportional. So I can look for the multiplicative relationship both vertically and horizontal, and it has to always be there. Now we're going to create a table of a proportional relationship and a relationship that is not proportional. Let's start with making it proportional. Let's just make it simple here. My x is going to be 1, 2, 3, and 4. So my multiplicative relationship would have to have the same going across. So I could say multiplied by 3 the whole way down. So that would give me 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. Now I don't need to check for their multiplicative relationships going this other way, although they will be there because this is there. That makes sense. But I can check just to make sure. So 1 times 3 is 3, 3 times 3 is 9. Can even check for some more here. 2 times 2 is 4, and 6 times 2 is 12. Now let's make a table that is not proportional. Again, let's just start with 1, 2, 3, 4. So going across, it's not going to be constant. So I'm going to multiply by 2, by 3, by 4, by 5. And that's going to give me 2. 2 times 3 is 6. 3 times 4 is 12. 4 times 5 is 20. So even though there was a pattern there, it's not the same, so it's not proportional. Next, let's see what proportional relationships look like on a graph. I know right here that this table is proportional because I am multiplying by 1/2 or dividing by 2 as I go across between the x's and the y's. So it is proportional. Let's take a second and graph that. So I have 0, 0, 2, 1, 4, 2, 1, 2, 3, 4, 5, 6, 1, 2, 3. Now ideally, this graph should be numbered. I'm just going to take a second and quickly number it. All right, and then let's connect the points and we can kind of see what that looks like. Let's look at this next one. Let's check if it is a proportional relationship. If I go 1 times 3, 4 times 3, 5 times 3, and 8 times 3, that will always work for my y's. I don't need to check this way, but I can if I need to. 1 times 4 is 4, 3 times 4 is 12, and I can even check like 4 times 2 is 8, 12 times 2 is 24. Let's go ahead and graph this. I'm going to go by ones here on the bottom, but on the side I need to go all the way up to 24. So let's go by 2s. I'll mark this 4, 8, 12, 16, 20. I ran out of a little bit room for the top, but that's going to be 24 there at the top. Let's graph this. So I have 1, 3, 4, 12, 5, 15, and then 8, 24. About right there. If I connect all these dots, my graph is going to look like this. Let's look at the next one. 0 times anything will give me 0. So let's check the next one and then we can compare it. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. Since these are not the same, this is not going to be a proportional graph. Let's go ahead and graph it and see what it looks like. I'm going to go by ones here and then up the side. So I have 0, 0, 1, 1, 2, 4, and 3, 9. So if I graph it, it's going to kind of look like this with a little bit of a curve going. All right, and that is not a proportional relationship. Let's look at the next one. 1 times 3 is 3. 3 times 3 is not 7. 5 times 3 is not 11. And 7 times 3 is not 15. So this is not a proportional relationship, but let's still take a second and graph it. We'll go by ones here at the bottom. And then up here on the side, let's go by 4s again. Well, I guess it's by 2s. I'm just only writing every other one. Okay, and let's graph it. So I have 1, 3, which is about right there. 3, 7. 5, 11. and then 7:15. And then if I connect these, it's going to be a graph about right that. So it's actually not going through this origin here. So zooming out here, the table/graph of A and B are examples of proportional relationships. And then the table graph of C and D are examples of non-proportional relationships. Analyze the proportional graphs on the previous page. What are two common characteristics of proportional graphs? So let's flip back to this page over here, and we're going to look at this. And we know that these two up here are proportional, and we know that these two down here are not proportional. So we've got to see what's common and what's not common. If you notice that they are straight lines, the proportional relationships are always straight lines. Now that can be true of a non-proportional relationships. That's why there's two characteristics. The other characteristic you notice, it has to go through the origin. So it has to go through the origin and be a straight line. It can't just be one or the other. Because this one right here, C, is going through the origin, but it's not a straight line. And D is a straight line, but it's not going through the origin. So the two characteristics are straight line and goes through the origin, or the point 0, 0. So let's go back and write that on our notes here. Okay, now let's look at these graphs here below. We're going to circle the graphs below that show a proportional relationship. So remember, we're looking for two things, a straight line and goes through the origin. So let's look at this one right here. It is a straight line and it passes through the origin. So that is a proportional relationship. Let's look at this next one right here. This is not a straight line. It does pass through the origin, but is not a straight line, so that is not a proportional graph. This next one right here, again, it is a straight line, yes, but it does not pass through 0, 0 or the origin, so this is not a proportional graph. This next one down here, not a straight line and doesn't pass through the origin, so that doesn't work with either of them. Not a proportional relationship. This one right here, straight line, goes through the origin. Let's circle that one. And this last one is a straight line and it passes through the origin, so that is another proportional relationship. Explain how you can use a graph to check if the relationship is proportional. So remember, we look for two things. We look to see if the line is straight, and we look to see if it passes through the origin or the point 0, 0. Okay, let's look at this one. The total cost is proportional to the number of pounds P purchased at the constant price. So we need to write an equation for this. So the total price T equals the number of pounds purchased multiplied by the cost of each pound. So T equals DP, or you could also write T equals PD. That just means the how many pounds purchased multiplied by the price per pound. And we're going to explain that here in words. The total miles driven T is proportional to the number of miles driven M at a constant speed. So same idea. The total miles driven T is equal to the number of miles driven multiplied by the constant speed. So number of miles driven multiplied by the constant speed of S. So T equals SM. The total cost T is proportional to the number of books purchased at the constant price of $5 a book. So to figure out the total cost, I'm going to take how many books are purchased and multiply it by the constant price of $5. Now this time it gives me the cost, so I'm going to write $5. So 5 times the number of books will give me the total cost. T equals 5B. The total number of pages read T is proportional to the number of minutes read at the constant rate of 1.5 pages a minute. So we need to write an equation for that. So the total number T is equal to the number of minutes read times 1.5 pages. Okay, now we need to create two proportional relationships and write the equation for each of them. Let's think about driving a car. Let's say I'm on the highway and I am driving 70 miles an hour. So I can figure out my total miles driven if I figure out how many hours I'm driving. So if I multiply 70 by how many hours I drive, I will get the total miles that I drove. So the total miles equals 70 times how many hours I drive. Let's say I'm going to the movie. I want to buy tickets that cost, let's say, $8 per ticket. I can get my total cost that I pay if I take the constant rate of 8 and multiply it by the number of tickets that I buy. Now let's combine graphs and equations. This graph below shows a proportional relationship between plant height and days passed. And just a quick look at the graph, I notice it's a straight line and that it passes through the origin. So it's showing me the height of a plant after how many days have passed. The point 2, 1 on the graph means, which is going to be this point right here, 2, 1, which means on day 2, the plant is 1 inch tall. Okay, now let's look at the point 0, 0. And what does that mean? Well, that means on day 0, the plant was 0 inches tall. Now let's look at the point 1 and 0.5. So 1 is 0.5, which is going to be right there. That means on day 1, the plant is going to be 1/2 inch tall. Okay, now on this part, it's asking me for the equation. So my equation is going to be my y-axis equals, so the height of the plant h equals my d-axis d multiplied by the constant rate. My constant rate is how much is happening every single day. How much is it growing every day? Well, if on day 0 is 0, day 1 it was 1/2 inch, and then day 2 it was 1 inch, that means it's growing 1/2 inch every day. So my equation will be h equals 0.5, which is my constant rate, times d. This graph below shows a relationship between total cost t, and I can see that here on my y-axis, and the bottles sold b, which is on my x-axis. The point 0.39, which I'm going to graph right here, the point 0.39 on the graph means, well, when I had 3 bottles, it cost me $9. The next point 0, 0, right here, this means when I had 0 bottles, it cost $0. Now let's look at the point 1,3. So 1,3 is going to be right here. This means when I had 1 bottle, it cost me $3. The equation for the line is, so remember my equation is going to be my y value t equals some constant times my x value b. So my constant is how much is it growing for every 1. So if I am at 0, 0 and then I go over 1, I increase by 3. Every time I go over 1, I am increasing by 3. You see that? That means the constant is 3. So my equation will be t equals 3b. Okay, now we're going to talk about constants of proportionality. The table below represents a proportional relationship. I am multiplying by 2 from all my x's to all my y's. Write an equation for this table. So my y equals my x variable, which is x in this case, multiplied by the constant relationship there, so 2. So I can figure out y by taking whatever x is and multiplying it by 2. Let's look at it for this one. If I have my x value of 2, I can multiply by 4 to get my y value, and that works the whole way around. What is the multiplicative relationship between x and y? Well, that's 4. Write an equation. So y equals, what do I do to x to get to y? I multiply by 4. So y equals 4x. Let's keep going. What's the multiplicative relationship here? Now you may notice that it's divided by 4, right? 8 divided by 4 is 2, 12 divided by 4 is 3, and I'm going to write that out to the side here. That is true, but it's asking for the multiplicative relationship. So divided by 4 is the same as multiplying by the reciprocal. So it's multiplying by 1/4. So if you notice the division first, that's good, that's fine. Just change it to multiplication by multiplying by the reciprocal of it. So the multiplicative relationship is 1/4. Write an equation. So what do I do to x to get to y? I multiply it by 1/4. Where do you see the multiplicative relationship in the equation? So what I want you to notice is that the multiplicative relationship is the constant. It is the number that is being multiplied by the x variable. We are going to give another name to that. The multiplicative relationship between x and y in a proportional relationship is also called the constant of proportionality or the unit rate. So we have three terms here. We have multiplicative relationship, we have constant of proportionality, and we have unit rate, and they all mean the same thing. Below is an example of a proportional relationship in the form of a verbal description, a table, graph, and equation. The constant of proportionality is given in the middle. Circle where you see the constant of proportionality in each form. Then create your own proportional relationship and write it in the form of a verbal description, table, graph, and equation. Okay, so let's figure out what the constant of proportionality is. We realize, so let's look at our table. To get from 1 to 2.5, I'm going to multiply by 2.5. And that is true from all these P's to all these D's. So my constant of proportionality is right there in my table. It's right here in my equation. And if I read the verbal description, it says, Pedro went to the market and bought 1 pound of apples for $2.50. So right there is my constant of proportionality. And I can see it in my graph right here. I can see for 1, it is $2.50. For every 1, it's 2.5. So that is my constant of proportionality. I'm going to create my own now. Let's start with my table. I have x, y. Let's just go 1, 2, 3, 4. Now if I multiply each by, let's say, 3, that's going to give me 3, 6, 9, 12. So my constant of proportionality is right here in my table where I'm multiplying them by. So my equation would be y equals my constant of proportionality times x. And in this case, I wrote my constant proportionality as 3. Let's write that here in the middle. On my graph, let's label this x and y. And quickly take a second and label the graph. So I can just use the points from my table to make it a little bit easier if I need to. So I have 1 is 3, 2 is 6, 3 is 9. So here's my graph. My constant of proportionality, I can see what it is when it's 1. So that's 1, 3, right there, 3. Or for every 1, I go up 3. My verbal description is just, I make something up where my unit rate is 3. So I could say like, my lemonade stand sells 3 glasses of lemonade every hour. And then I can see my constant of proportionality right there where it says 3. So constant of proportionality, multiplicative relationship, unit rate, all the same thing, and you can see them in descriptions, tables, equations, and graphs. Okay, that's it for today. Thank you.